meet Geometro Ninjas, and welcome to another enthralling class of geometry. Today we're talking about tangent lines. Okay, so if you think back to that first day, we talked about definitions. Tangent lines are lines that touch our circle at exactly one point. The point that those lines touch our circle is called the point of tangency. Okay. So today our tangent lines have some very specific rules that are going to allow us to determine whether or not a line is in fact tangent to a circle. So if a line is tangent, if and only if is what kind of statement? Biconditional, great answer, meaning it's true both directions. So if it's perpendicular, it's got to be tangent. Okay, so if and only if it is perpendicular to a radius, and both of them are drawn at a point of tangency. So our first examples, we want to determine whether or not AB is tangent to circle P. All right, so we look at our example. So A would be our point of tangency. Turn your pen on, dummy. Okay, A is our point of tangency. We've got a radius AP. And then our tangent line is out here. And that is AB. Okay, so where my tangent line and my radius are intersecting, that is called the point of tangency. And remember, it is important to know these rules or these definitions, because maybe, just maybe, on Friday, we'll know. Okay, so our point of tangency, if this is true, it's going to form a right angle. Well, how can we verify whether or not something's a right angle if we know three sides? The Pythagorean converse, great. So remember, if we think back, way back, so if C squared equaled A squared and B squared, it was a right triangle. If C squared was greater than A squared plus B squared, it was obtuse. And if C squared was less than A squared plus B squared, it was acute. So we're going to use our Pythagorean theorem converse to determine whether or not AB is actually a tangent line. So we take our longest side, 17, and we want to know in relation to the other two, is it equal, greater than, or less than? So 17 squared is 289. 8 is 64. 15 is 225. Combine like terms on the right side, we get 289 is what in relation to 289? That is equal, which means that this is in fact a right triangle. So is AB tangent to our circle? The answer is yes. So the Pythagorean converse allows us to test whether or not two things are tangent. All right, let's take a look at number two. Number two. So this is where our point of tangency occurs. But they kind of mess with us a little bit. They didn't give us the full length of that side. What if I was talking about just this? What would just that segment be? What would that be in relation to the circle? A radius, great answer. Y'all can talk, weirdos. Okay, a radius. Well, do we know the measure of our radius? Did they tell us the measure of a radius? No. So what's this? That's a radius. So if that radius is 11, the other radius has to be 11 because all radii in a circle are congruent. So the full length of this line is actually 16. So we're going to use our Pythagorean converse. So c squared is 16 squared is what in relation to 14 squared plus 11 squared? $16 squared is 256. 14 is 196, and 11 is 121. So 256 is what in relation to 317? It is less than. So does this form a right angle? No, it does not. Meaning that AB is not tangent to the circle. It has to form a right angle. That's the rule. Unfortunately not. We can't just look at a lot of things and assume. We got to prove it mathematically. Did you think that one touched it more than once? No, I just don't. Oh, you're talking about the angle itself doesn't look right. Yeah, we can't do that because printer error and all kinds of shenanigans. All right. Well, they're telling us that JK is tangent now. They said, hey, JK is tangent. And to make that true, find X. How do we find the third side if we know 2 out of 3? That's right, our homie Pythagoras. A squared plus B squared equals C squared. A squared plus B squared equals C squared. A and B are my legs, C is my hypotenuse. So remember, our point of tangency is going to be where our right angle occurs. So we get 7 squared plus 19 squared equals C squared. 49 plus 361. 49 and 361 is 410. We're trying to solve for C. How do we undo a square? Yeah, with a square root. Okay. And the square root of 410 is approximately 20.2. Let's do number 5 because it's gonna upset you a little bit. Okay, so number 5, they kind of hit us with that missing side again. Well, that side is simply a radius. And we know in any given circle, all radii are always congruent. So if one radii is 10, the second radius has to be 10. Anybody see why you're going to be annoyed with this yet? No? Let's keep going. So the full length of this side is actually x plus 10. All right, so remember, we're using Pythagorean theorem. A squared plus B squared equals C squared. So we get 24 squared plus 10 squared equals X plus 10 squared. There it is. But don't panic. You can solve it using the square root property. Okay, 24 squared is 576. 10 squared is 100. And we're going to leave that binomial attached. We don't want to really mess with that yet. So we get 676 equals X plus 10. Square root property tells me that to get rid of a square, I can square root both sides. So we square root both sides. What's the square root of 676? 26. So 26 equals X plus 10 because that square is canceled by that square root. Subtract 10 from both sides. So we found X to be 16. So it looked a little frightening. All right, let's hop across to 6. So they keep trying to trip you guys up by leaving portions of our triangle blank. ML is simply another radius. And we know the radius of this triangle is 11. So if the one radius is 11, every radii in a triangle have to be congruent. So if one radius is 11, the other one has to be 11, making the full diameter 22. Because MJ is simply a chord that passes through the center. So instead of being a basic chord, it makes it a diameter. Chord is a segment with endpoints on the circle. Pythagorean theorem, a squared plus b squared equals c squared. So c squared is 25. We get 22 squared plus x squared. How did I know 25 was the hypotenuse? Well, if it's going to be tangent, it's got to be tangent right there. So our right angle, hypotenuse is always across from the right angle. All right, 22 squared is 484. Plus x squared equals 625 squared, or just 625, excuse me. Subtract 484 from both sides. X squared is 141. And then to undo our square, we're going to square root both sides. So X is approximately 11.9. So don't let them trick you with the missing radius. Let's bounce on down to 8 because 8 throws another one at us. Got a missing radius. But we know the radius of this circle is actually X. So the full length would be 2x, not x squared. We're not multiplying our x's together. We're adding them. X plus x gives us 2x. Okay, so going to our Pythagorean theorem, 2x squared plus 7 squared equals 25 squared. Sorry, you guys can't see that. 2x squared is 4x squared plus 49 equals 625. So remember, power to a power applies to everybody. So when we're raising that power, we're not just applying the power to the variable. The power has to go to the constant too. Constant words, Sean. Okay, subtract 49, constant. Got Wordle on the brain. 625 minus 49 is 576. And again, we're trying to solve for x, so we divide both sides by 4 first. X squared equals 144. To get rid of our square, we're going to square root. So x is exactly 12. Any questions on those? No? All right, let's move to a couple more rules. So some more properties of tangent lines. If two segments from the same external point, so we're talking about this external point B out here. If those two segments are both tangent to the circle, we know they're tangent because they meet the radius at a right angle. If they are both tangent to the circle, then they are congruent. And then our second property, if a polygon is circumscribed around a circle, then all of our sides are tangent. Meaning BD is congruent to BE, CE is congruent to CF, and AD is congruent to AF. That does not mean that all of our sides are congruent. They could be. We could have an equilateral or square or something like that. However, it does say that if you've got that polygon circumscribed, meaning a circle is inside of a polygon, then our sides are tangent. And then using the property next to it, you would know that since they're tangent to the same external point, they have to be congruent to one another. So we cannot assume that all of our sides are congruent based solely on this rule. We would need to prove it. Y'all ready to use our rules? Yeah, you are. All right, so we want to find the value or measure. They want us to find the measure of x. Okay. If they appear to be tangent, so they're telling us, hey, any segment that appears to be tangent is tangent. Otherwise, we would need to see what? Yeah, dude, that right angle. That's what we want to see. So we've got an external point with two tangent lines. If two lines are tangent to the same external point, then the segments are congruent. So we know that BC is equal to BA. So that's how we're going to set up our formula. 8x minus 19 equals 5x plus 23. And then it becomes simple algebra problem. Add 19 to both sides. Subtract 5x from both sides. Those guys are going to cancel. So we get 3x equals 42. Divide both sides by 3. So x equals 14. And if we wanted to check our work, we could substitute that in. 8 times 14 is 112. 112 minus 19 is 93. Same thing, 5 times 14 is 70. 70 plus 23 is 93. So both links are 93. Let's come straight down to 12. 12 wants us to find the length of SV. I like 12 a lot because 12 makes us do two things. We first need to find X. And we've got to find X first. And then we're going to use what we were doing on the first page to find the measure of SV. So we know these are tangent because they said assume they're tangent. They don't tell us that, we can't assume it. So we've got our common point S. We've got our two tangents, so we know that these guys are congruent. That's how we're going to solve for X. So 10x minus 41 equals 4x plus 7. Add 41 to both sides and subtract 4x from both sides. 10x minus 4x is 6x, and 7 plus 41 is 48. Divide both sides by 6 now. So x is 8. That's great. We know what x is, but that's not what the question's asking us. It wants us to find SV. So we need to substitute that value we just solved for. So 10 times 8 minus 41. 80 minus 41 is 39, I believe. Should be. So now to find SV, we just go back to our homie Pythagoras. So we say 39 squared plus 17 squared equals SV squared. SV is my hypotenuse because it is opposite the 90. $39 squared is a massive number that I do not have memorized. 1521 plus 289. 1521 and 289 are 1810. To get rid of a square root, to get rid of a square, we apply the square root. So the measure of SV is approximately 42.5. Such a good math problem. Makes you do two things at once. All right, let's do 13, then I'll set you free. Okay, find the perimeter of triangle DEF. Perimeter means distance around. So we've got to be able to add up all the side lengths. Maybe we should have focused on 4. Okay, so D is our common external point. So we know that DG and DH are congruent. Same thing for EH and EI, because Bingo was his name-o. And then FG and FI. All of those are going to be congruent because of our first tangent property. If two tangent lines share the same external point, they have to be congruent. So this line is 11. This line is 16. And our bottom line is 9.5. So to find the distance around, we're just going to add them all together. So we know there's 2 11s, 2 16s, and 2 9.5s. 2 times 11 is 22. 2 times 16 is 32. 2 times 9.5 is 19. We add them all together. We know the perimeter is 73. All right, that's going to conclude our lesson on tangent lines. Everybody have a good day.